What if I told you that beneath your feet, right now, the ground isn't as still as it seems? In just the last few days, 847 seismic events have rattled California's crust. Not one, not 10, 847. That's not background noise, that's movement. That's pressure shifting deep below the surface where no one can see, but everyone would feel the consequences. And here's where it gets serious. Scientists aren't just counting tremors, they're analyzing something called stress transfer, a powerful geological process where energy released in one location doesn't disappear. It migrates, it redistributes, it loads nearby fault lines with additional strain. Think of it like pulling on one thread of a tightly stretched fabric. The tension doesn't stay isolated, it travels. Is this just another routine swarm in a state famous for earthquakes? Or is this the kind of clustered activity that sometimes shows up before something much larger unfolds? No hype, no fear tactics, just facts. California sits on some of the most studied and most dangerous fault systems in the world. History has shown us what these systems are capable of. But science has also evolved, and so has our ability to monitor subtle warning patterns beneath the surface. Tonight, we break this down clearly, calmly, and powerfully. Because understanding what's happening below the crust isn't about panic, it's about perspective. Stay with me. What you're about to learn could completely change how you think about seismic swarms, stress transfer, and the ever-present question, is the big one building quietly right now? Over the past several days, seismic monitoring stations across California recorded 847 tremors. That number alone grabs attention. But numbers without context can mislead, so let's ground this in reality. California is one of the most seismically active regions in the United States. Thousands of micro-earthquakes happen here every single year. Many are so small they barely register beyond sensitive instruments. You don't feel them, you don't hear about them. They come and go like quiet pulses beneath the surface. So 847 tremors doesn't automatically mean catastrophe. But here's where it becomes worth examining. It's not just the count, it's the pattern. When earthquakes cluster tightly in a specific region, within a compressed window of time, especially near known fault systems, scientists don't shrug it off. They zoom in. They analyze depth, magnitude distribution, spatial alignment, and timing intervals, because clusters can signal something more dynamic happening underground. Imagine tapping repeatedly on a frozen lake. One crack, maybe nothing. But multiple cracks spreading in one area, that tells you the structure underneath is adjusting. The Earth's crust behaves similarly. It's constantly under pressure from massive tectonic plates grinding past each other. When a series of tremors occurs close together, it can indicate that stress is shifting, unloading in one pocket and loading in another. That shifting of force is what geologists call stress transfer. Energy released by one quake doesn't vanish. It redistributes along connected fault lines, sometimes increasing strain elsewhere. Does that guarantee a larger quake? No. But it does mean the system is active, and active systems demand attention. This isn't about panic, it's about understanding movement beneath our feet. Imagine holding a thick metal ruler in your hands. You bend it slowly. The pressure builds at the center, but the tension doesn't stay there. It travels outward along the entire strip of metal. Every inch feels the strain. Now imagine that ruler snapping. The force released at the break doesn't vanish into thin air. It ripples outward, it shifts, it redistributes. That's a simplified version of what scientists call stress transfer, and it's happening miles beneath California right now. The Earth's crust isn't solid and still like concrete. It's fractured, segmented, and constantly under pressure from massive tectonic plates grinding past one another. When a small earthquake occurs, it releases built-up stress at that exact point along a fault. But here's the critical part. That released energy doesn't simply disappear. It moves. It redistributes along neighboring sections of the same fault, or even onto connected fault systems nearby. Think of it like shifting weight on a cracked windshield. Press in one corner, and spiderweb fractures react elsewhere. This process can do two things. First, it can relieve stress in certain areas, slightly lowering the likelihood of immediate rupture there. Second, and this is where scientists focus, it can increase stress on adjacent fault segments that were already under pressure. If a neighbouring segment was close to its breaking point, even a subtle increase in load could raise the probability of movement. Not certainty, probability. And in earthquake science, probability matters. Researchers use advanced computer modelling to calculate what's called Coulomb stress change. These models estimate how much force has shifted, where it moved, and whether it brought surrounding faults closer to or farther from failure. Most stress transfers result in nothing dramatic. The system absorbs the change, the crust adjusts, life goes on. But occasionally, in rare and complex scenarios, stress transfer has preceded larger events. That's why scientists don't ignore clusters. They monitor them. They compare historical patterns. They analyze magnitude progression, depth migration, and spatial alignment. This doesn't mean a major quake is guaranteed. It means the Earth is adjusting. And when adjustments happen along major fault systems, experts lean in, watching carefully, calmly, and very, very closely. The fault lines at the center of attention. This is California's most infamous fault system. Stretching roughly 800 miles from the Salton Sea to northern California, the San Andreas marks the boundary between two massive tectonic plates, the Pacific Plate and the North American Plate. These plates are constantly grinding past one another, not smoothly, but in jagged, locked segments that store enormous amounts of strain. When that strain finally releases, the results can be historic. The 1906 San Francisco earthquake, the 1857 Fort Tejon event, massive ruptures that reshaped landscapes and rewrote building codes. Today, the San Andreas remains one of the most intensely studied fault systems on Earth. Sensors track its motion down to millimeters. Scientists map its stress load in real time. Because when clusters of seismic activity appear near major segments of this fault, researchers immediately analyze whether stress redistribution could influence it. Hayward Fault, running directly beneath densely populated Bay Area communities, the Hayward Fault is often called one of the most dangerous urban faults in America. Why? Because it cuts through cities, not deserts, homes, schools, transit lines, freeways. Based on historical recurrence intervals, many scientists consider this fault overdue for a significant event. That doesn't mean it will rupture tomorrow, but it does mean it's carefully monitored, especially when nearby seismic clusters raise stress calculations. Los Angeles. Now think about Los Angeles. Millions live in and around this region. Infrastructure webs through the city like arteries. Highways stacked in layers, skyscrapers engineered to sway, water systems crossing fault traces underground. Everything is interconnected. When stress shifts along major systems, urban centers don't just feel tremors, they feel the implications, economically, structurally, socially. This is why scientists track stress transfer so carefully. Because along these fault lines, movement isn't just geological, it's personal. Let's lower the temperature and raise the clarity. When headlines explode with numbers like 847 seismic events, it's easy for imagination to run ahead of science. But here's what experts actually say. Clusters of small earthquakes, often called swarms, are common in tectonically active regions like California. The state sits along shifting plate boundaries. Movement is constant. Microfractures happen daily. Most of them are part of the Earth's normal adjustment process. And here's the key fact. Most swarms do not trigger major earthquakes. That's not opinion. That's historical data. Now that doesn't mean scientists ignore them. Quite the opposite. When a cluster forms near known fault systems, researchers run stress transfer models. These advanced calculations measure how much force may have shifted and whether nearby segments experienced an increase or decrease in load. Sometimes the probability of rupture increases slightly. Sometimes it decreases. Sometimes the effect is statistically negligible. Notice the word probability. Earthquake science is not about prediction. No one can point to a calendar and circle a date. There is no countdown clock buried under California. No red flashing warning system saying 7 days remaining. Instead, scientists operate in risk forecasting. They analyze historical rupture intervals. They study fault locking depth. They monitor ground deformation using GPS. They calculate Coulomb stress changes. All of this builds a probability landscape, not a prophecy. And probabilities matter. Even small percentage shifts influence preparedness strategies, infrastructure planning, and emergency management readiness. But they are not guarantees. There is no confirmed signal that a major earthquake is imminent. What there are patterns. Patterns in frequency, patterns in location, patterns in stress redistribution, and those patterns are watched carefully, calmly, relentlessly. Because awareness is scientific responsibility, not sensationalism. It's not just the number. California records thousands of quakes every year. On paper, 847 tremors can sound dramatic, but in isolation, numbers don't tell the full story. What makes this cluster stand out is the concentration, the timing, the geographic tightness, the proximity to larger, historically significant fault systems. When seismic events scatter randomly across a wide region over months, that's background tectonic noise. But when they compress into a narrow zone within a short time frame, scientists begin mapping them carefully. Because clustering suggests something dynamic is happening beneath the surface. Picture a microwave with popcorn inside. Occasional pops here and there, completely normal. But when popping accelerates rapidly in one corner, tightly packed, increasing in frequency, you instinctively lean in. You pay attention, not because it guarantees something will explode, but because patterns shift before outcomes shift. Seismologists look at depth progression. Are quakes migrating upward or laterally? They analyze magnitude distribution. Are events gradually increasing in size? They examine fault orientation. Are tremors aligning along a known locked segment? These details matter more than raw totals. Clusters near major systems can mean stress is redistributing in a focused way. And when stress moves, it can subtly alter conditions on adjacent segments. Again, and this is critical, this does not confirm a major rupture is imminent. There is no verified signal that the big one is about to strike. But concentrated seismic bursts raise analytical eyebrows, because historically some larger earthquakes have been preceded by swarms, not all, not even most, but enough to justify close observation. 847 tremors alone don't define the future. But the pattern behind them, that's what scientists are watching, carefully, calmly, and without blinking, the big one. Just hearing those three words can tighten your chest. In California, the phrase has lived in public consciousness for decades. It refers to a hypothetical large-scale earthquake, often magnitude 7.8 or greater, along major fault systems like the San Andreas Fault. But here's something powerful to understand. The big one is not a scheduled event. It's not a ticking bomb with a visible timer. It's a probability scenario, one built from geological history and long-term plate motion. Media headlines often amplify the dramatic angle. Social media amplifies speculation even faster. And in the digital age, fear can spread across millions of screens in minutes. But reality is more nuanced than a viral headline. California has spent decades strengthening its defenses. Modern building codes are among the strictest in the world. Skyscrapers are engineered to sway instead of snap. Bridges are retrofitted with flexible joints. Hospitals and emergency centers are reinforced to remain operational after major shaking. Early warning systems now provide precious seconds of alert before strong shaking arrives. That may not sound like much, but seconds save lives. Seconds shut down trains. Seconds pause surgeries. Seconds allow people to drop, cover, and hold on. Infrastructure reinforcement continues every single year. Preparedness campaigns educate families. Schools run drills. Businesses update emergency protocols. Is risk still present? Absolutely. But preparedness today is dramatically stronger than it was 30 years ago. Fear spreads faster than facts. But knowledge builds resilience, and resilience, not panic, is what ultimately determines how communities respond when the ground moves. So let's bring this into sharp focus. What would stress transfer actually mean in practical terms? If a cluster of earthquakes significantly increases load on a neighboring fault segment, a few things could happen. It could slightly increase the likelihood of rupture along that adjacent section. It could trigger a sequence of moderate aftershocks in nearby zones. It could accelerate movement on a segment that was already quietly accumulating strain. Notice the word could, not will, not guaranteed, could. Because earthquake mechanics are among the most complex systems studied in earth science. Faults aren't smooth cracks waiting to unzip. They are jagged, irregular surfaces locked together by friction. Some sections are tightly stuck, others creep slowly. Rock strength varies from 1 mile to the next. Fluid pressure deep underground can lubricate or resist motion. Temperature and depth conditions influence how brittle or ductile the crust behaves. It's a layered, dynamic, constantly adjusting system. That's why, even with advanced modeling, scientists speak in probabilities, not promises. Stress transfer is like adding weight to one side of a scale. Sometimes the scale tips, sometimes it holds, sometimes the added weight redistributes again before anything significant happens. History shows that most seismic swarms end quietly. The crust shifts, energy balances, activity fades. 847 tremors do not automatically equal disaster, they equal movement, and California exists in a state of movement. The Pacific Plate and the North American Plate are constantly grinding past each other at about 2 inches per year, roughly the speed your fingernails grow. That motion doesn't stop, it doesn't pause, it builds, it releases, it adjusts. Stress transfer isn't a countdown, it's a reminder. The Earth beneath California is alive, dynamic, and always in motion, and understanding that motion is far more powerful than fearing it. Instead of panic, prepare. Because fear without action creates anxiety, but preparation creates confidence. If you live in California or anywhere in an earthquake-prone region, there are practical, proven steps that dramatically reduce risk. First, secure heavy furniture, bookshelves, TVS, dressers, water heaters. These cause more injuries than collapsing buildings during moderate quakes. Anchor them to wall studs. It's simple, it's affordable, and it matters. Second, know your drop, cover, and hold on position. When shaking begins, drop to the ground, take cover under a sturdy table or desk, and hold on until it stops. Do not run outside, do not stand in doorways in modern homes. Most injuries happen from falling objects, not structural collapse. Third, keep emergency supplies, at least 1 gallon of water per person per day for 3 days, non-perishable food, flashlights, batteries, a first aid kit, portable phone chargers. Small preparations make massive differences in the first 72 hours after a major event. Fourth, review your family communication plan. If cell networks are overloaded, know where to meet. Choose an out-of-state contact person, practice it like a fire drill, because clarity during chaos saves time and time saves lives. Preparedness isn't paranoia, it's empowerment. Statistics consistently show that communities with higher readiness experience fewer injuries and faster recovery times. Building codes help, emergency response teams help, but personal preparation multiplies survival odds. You cannot control tectonic plates, but you can control your readiness, and readiness changes everything. Preparedness reduces anxiety, action replaces helplessness, and when the ground eventually moves, because in California it always does, preparation turns uncertainty into resilience. Step back for a moment, zoom out beyond the headlines, beyond the numbers, beyond the fear. The Earth is dynamic. It has always been dynamic. California sits along one of the most active tectonic boundaries on the planet, where the Pacific Plate and the North American Plate grind past each other mile after mile. That motion didn't start yesterday. It won't stop tomorrow. Seismic swarms happen, stress shifts happen, energy redistributes constantly beneath the surface. Movement is not the exception here, it's the rule. 847 tremors are not a prophecy. They are part of a living, shifting system that has shaped mountains, coastlines, and entire cities over millions of years. The real danger isn't movement, it's complacency. The key question isn't, is the big one tomorrow? Because no scientist can answer that with certainty. The real question is far more powerful. If it happens next year, or 10 years from now, are we ready? Are our homes secure? Are our families informed? Are our communities prepared? Because readiness transforms uncertainty into strength. And strength, not fear, is what defines how we endure when the ground moves. 847 seismic events. Stress transfer calculations underway. Scientists watching carefully. No confirmed major rupture. No official warnings of imminent disaster. But heightened awareness? Absolutely. This isn't about panic. It's about perspective. The ground beneath California is always moving. What matters is how we respond to that reality. With fear or with preparation. If this breakdown gave you clarity instead of chaos, comment below. Prepared, not panicked. Because knowledge is power, preparation is strength, and calm awareness defeats fear. Every single time. Stay informed, stay grounded, and above all, stay ready.